Good morning. It's time for Pythagoras and the parts of right angle triangles. I'm going to try that because if I have the lights on this side of the room, I get a glare. All right. We call the side opposite to the right angle. This is a 90-degree angle, commonly called a right angle. Side opposite is called the hypotenuse. And if we draw it like this is the right angle, okay, commonly called a right angle. The side opposite the right angle is called the hypotenuse. This is something that is common to all mathematicians around the world. So the side opposite to the right angle is the hypotenuse. This only works with right angle triangles. There is no hypotenuse if there is not a 90-degree corner, okay? There has to be a vertex with 90 degrees. Now, when we use this right angle work, right angle triangles, okay, there has to be a 90-degree corner, and we call that a right angle, because when you build houses, or in the case of the Romans and the Greeks, temples, and you're a bit off, instead of 90 degree corners, you've got crooked corners. Rock tends to tip over and crash and kill people. So they didn't want wrong angles, they wanted right angles, straight up and down. So when they measured their angles, they needed it to be this way. And it's the same in India where they got this idea from. So we have a formula, and the guy's name is Pythagoras, who popularized this in Western culture. A squared plus B squared is equal to C squared. Now, there's a couple things about this. If we always have C squared being the hypotenuse, C being the hypotenuse, C is the hypotenuse, C is the hypotenuse, C is the hypotenuse, C is the hypotenuse. If C is always the hypotenuse, this works fine. You could have A here or B here. Doesn't matter. Doesn't matter. There you go. Works good. Now, A squared plus B squared is equal to C squared. We're going to give you A and B, and you're going to find C. So I'll start with this one here, and we'll just make the formula here. You do these three on your own once I put the numbers in place, okay? So we'll make, we'll try and find C. A is going to be 3 meters. B is going to be 4 meters. And we'll see what C is. So we have 3 squared plus 4 to the power of 2 equal to C to the power of 2. And I'll show you a bit about why that works in a few minutes. 3 squared, 9, plus 4 squared, 16, gives us C squared. And then 9 plus 16 is 25, equal to C squared. Now, to get C, what do you have to do to this to get C? Well, square root it. So, square root here, square root here. Okay? Square root of 25, what number multiplied by itself is 25? 5 times 5, so we have 5 here. Square root of 25 is 5. 5 times 5 is 25. Square root of C squared is C. C is equal to 5 meters. Okay? So use this formula and how to do this to find all of these. I'll give you some numbers here. Let's see. We'll make this one 12 centimeters. And let's call these A, B, C, and D. 12 centimeters, 16 centimeters. What's C? Okay, this one here, let's make this one 24 centimeters, and we'll make this one 18 centimeters. What's this one? And then this one here, let's make this one 33 inches, and we'll make this one excuse me, 44 inches. What's this one? Okay, so that's your first set of problems with regard to Pythagoras. Pythagoras. Here's how to spell Pythagoras. Pythagoras is a guy's name in Greek. He developed this, popularized it in Western culture. Some historians think he stole it from the people from India because about 1200 years earlier, this sort of formula was used there. All right, enjoy. That's your first assignment.